So before going into the definition of command design pattern, let's consider a scenario which we are going to solve using command design pattern. So this scenario is that I have to develop assembler application which has multiple features such as music player, audio recorder, video recorder, etc. So this assembler application, you can consider it as a mobile set which has multiple features: music player, audio recorder, video recorder, etc. And the implementation of the core applications such as music player, etc. should be decoupled with the assembler application, which means that I can change the music player vendor by just setting it into my assembler application without any code change. And the assembler application should support undoable operations, which means that if I have in my assembler application, if I have a feature of a music player, then if I turn that music player on, then it should be undoable and I should be able to turn it off as well. So now coming on to the textual um, definition of command design pattern. So it says that it encapsulates a request as an object. So if I relate it to the problem statement or the scenario, the request can be to turn the music player on, to turn it off, or to turn audio recorder on or off. So that will be my request and it will be binded to an object. Now the second point says it allows us to parameterize different objects with different requests. So it maps the different request with different objects. A request of turning on the music player will be binded to an object. The request of turning on the audio recorder will be binded to other object, and it supports the undoable operations. So if a request to turn the music player on is there, it should be undoable also. So what are the key classes which are in command design pattern? So first of all, we need an interface which defines the command contract. So I will show you all these things in the code, but for now just try to remember these key classes and interfaces. Then I should have a concrete command implementation of the command interface. So my interface can be defining some methods to get executed, and my concrete implementers will implement that, and there will be multiple concrete implementers for the feature of music player, the feature of audio recorder, etc. Then there should be a invoker who should invoke these features, and there should be a receiver. Receiver has the actual logic to implement that feature. So if I try to turn on the music player, then the actual music player application is my receiver who is going to do the job. So now let's go to some code and see how we are going to implement this scenario. So let's say this. I talked about a command interface which lists the methods which will be implemented by its concrete implementer classes. So in my command interface, I have a method called execute. I have a method called undo. So execute will be called to execute some feature, and undo will be there to stop that feature or um, undo what execute has done. So now this is my interface. Then I talked about concrete classes for this interface. So let's see one of the concrete class. This is music player on command, which implements this command interface, and it overrides the execute and undo method. And to this concrete implementation of command, I'm binding a music player type 1, which is like the actual music player which will be there inside my assembler application. There can be multiple vendors of this music player, so it is one of the vendor which provides the logic to play the music player. And this music player type 1 is nothing but my receiver, because if you remember, I told that receiver holds the logic to execute our request. So if from my assembler application I say turn on the music player and play some song, then it will be the receiver who is going to do that job for me for the assembler application. So if you see, it has a turn on method which will be called from this concrete implementation of command from execute method. Similarly, it will call the turn off method also from the undo method, and it is going to um, in turn call its own implementation. So when concrete class implementer calls this turn off method on this receiver object, this is going to execute its implementation to stop the music player. Similarly, for turn on feature also, it's going to do a list of actions, set volume, set song, set default song, and then start the music player. And now I also talked about different features. So command interface will remain same, and there will be one more implementer of this command interface, which will be audio recorder on command. Similarly, it's going to have its own receiver, audio recorder type 1, and it is going to override the execute and undo method, and it's going to turn it on and off, whose actual logic will be provided by the receiver class. When I say turn on, it's going to set the volume and start recording. When I say turn off, it's going to stop recording. And this implementation will vary based on different receivers. So now we have talked about receiver, we have talked about command interface, we have talked about implementers of this command interface. What is left is invoker, right? The invoker who is going to um, invoke this uh, implementation of command interface. So let's see that. So I have a client app. So what I'm doing here is I'm just um, binding the receiver to the implementation of command. One important thing which was there in the definition of command design pattern was that it binds the request to the object. So if you see here, this is my request, turn on music player, and I'm binding it to a object of command, right? So I'm binding the request to the object of command uh, implementer, and in turn command implementer is accepting a receiver. So I have my receiver, I have my concrete implementation of command, I am binding the request to this object, and then I am invoking it here. So I have binded it and kept it in a hash map to for demo purpose, and then from here I'm calling the request, I'm getting the object associated with this request, and I'll call say execute method, and then it should execute my the action which I want. So if you see here, this execute, when I'm going to call, it's going to go here to this audio recorder on command class, which is an implementation of command interface, and it's going to call this execute method, which in turn is going to call the turn on method on this receiver. So let's run that. So if you see, uh, it prints these two lines. Where it is coming from? It is coming from receiver, because my receiver holds the actual logic to fulfill my request. So what is my receiver? Music player type 1. So when I say execute, it in turn calls this uh, eventually calls this turn on method. It sets the volume. So I think I called it over audio recorder. Okay, so if you say this audio recorder type 1, first it sets the volume, so it prints this thing, and then it starts recording. If I have to undo this, I will simply, instead of execute, I'm going to call undo method. If I'm going to execute this, it's going to print this. Where it is coming from is from this command implementation. It goes here, then it calls the turn off method on this receiver object, and it then in turn calls the actual method which holds the logic to stop the audio recording or the or this feature, and it will print this line. So what I will say is just to remember the scenario, and whenever such scenario comes, then it can be solved, or it can be solved in a good way using command design pattern. So yeah, try to correlate the command design pattern features, its key classes, and the scenario plus the code, and then you will get a clear understanding on when this design pattern should be used. Thanks a lot, friends.